In this third part, we're going to start by taking a look at this table, showing the digestive hormones. And so I'm going to help you with understanding which ones are really important for you, for your course. So in the stomach, we have gastrin from the G cells. It's very important. And in the intestine, we have CCK, cholecystokinin. We also need to know about secretin and the gastric inhibitory peptides. So here you have it. You can look at this table for your reference. And in this summary slide, there you have an anatomy picture of the different processes that are taking place in terms of motility, secretion, digestion, and absorption, sort of highlight what's happening in each section of your gastrointestinal tract, so you can review that on your own. Now let's moving on to the different phases of your digestive processes. The first part is the cephalic phase. Cephalon is the head. That means we're really starting our digestive processes with, in our head. Let's say you see food, you smell the food, you want the food. So the cephalic phase is like, I'm looking at it and I want it. So that will start releasing chemicals such as saliva with digestive enzymes into the mouth. So you get this chemical mechanical digestion begins in the mouth. You eat the food, you chew the food, it's mechanical, and then you start chemical breakdown with the hormone, with the enzyme amylase. Salivary secretion is always under autonomic control. These are glands, and these glands, the purpose of their secretions is to soften and lubricate the food, and also you add the salivary amylase and some other enzymes as well. Saliva has also some protective function, and the process of chewing, the mechanical breakdown of your food, is called mastication. Make sure that you know this term. So here is sort of the cephalic phase. Means you see the food. I wish they would have put some better food choices there, whether it's cake, a burger, and I guess some chicken. Anyway, so you see the food, maybe you smell the food, and you think, oh my God, food. And then you're setting a whole sort of set of reactions in motion, and it leads to the production of saliva. It leads to the stomach anticipating food, and you have some of the processes that your stomach is going through right there, and here what your brain is going through. But the detail of this, you don't really need to know this. So here. So once you see the food and you smell the food and you want the food, eventually you are going to put it in your mouth, and this is what happens. As soon as you've chewed the food and mixed it with saliva, as soon as you push it back with your tongue, then it's called a bolus, and this bolus of food is going to go down your esophagus until it arrives in the stomach. Now here the gastric phase, so referring to the stomach. Of course, the three functions of the stomach are storage of food and digestion. Mostly what we're going to digest are some proteins, actually, and the stomach has some protective function. The digestive activity in the stomach begins with the long vagal reflex of the cephalic phase, and here's a summary of the secretory cells of the gastric mucosa. And here's some important information that you definitely need to know. So here the mucosal neck cells, it's all nice right here, and then we're going to one of those gastric pits here. The absolute must-know information: parietal cells, they secrete hydrochloric acid, and they contribute to the gastric acid. It's a must-know information. So parietal cells, hydrochloric acid. The chief cells here, they make a protein digesting enzymes is known as pepsin. Basically, you're activating a precursor, the pepsinogen, and then you make it into pepsin, and that's when you get protein digestion. So that will be the chief cells. And the D cells and the G cells, so we don't really need to focus on that right now. Okay, so here. This is another figure that seems more complicated and what the whole thing is worth it. So basically, you see food and you want it, and your stomach starts to get ready for the arrival of food, and then here you have input via the vagus nerve in the opposite direction, basically, and so then your enzymes in the villi of the stomach, they start to produce gastrin. They may also produce somatostatin. So I don't expect you to know this diagram in particular, but just know that the seeing the sight of food initiates the whole digestive process. And here we have the mucosa bicarbonate barrier. Basically, an endothelium cannot withstand this kind of pH. It would be way too acidic and these cells would normally die. So you have to come up with a trick to protect these cells. And basically, you are trying to create a bicarbonate chemical barrier to minimize the reduce of infection and also to minimize the risk of maybe dehydration. On panel B, you have the mucose bicarbonate barrier. And the way that works is that you're taking bicarbonate and sort of layering it protectively on top of your gastric pits, essentially, and that seems to be helping a lot, which makes sense. And I don't think we need anything else from here. Now here's another slide that seems more difficult than what is worth it. So it's supposed to be the integration of gastric intestinal phases. I think it's very crowded, but if you follow the arrows, I'm sure you can figure it out. And well, that's basically how crop foods are being modified to try to make it better products. But anyway, for better or worse, we'll see what the future holds. So in this image right here, it shows this person, and then the liver is enlarged right here, and then even more enlarged are the possibly infected areas. And so then they did analysis and found out that the cancer cells are in fact actually they came from the original donor, which was rejected at first, but it turns out it was true, and that's because we have genetic sequence analysis pretty readily available these days. Now here's another diagram that may not pass the test of time, but here we are faced with it right now. So it's the integration of gastric and intestinal phases. There's a whole lot of feedback going on all the time between the different places of your body, so you don't need to know the details of the discharge, but some of the items you should maybe sort of keep in the back of your head. Now moving on to the intestinal phase. The big thing is that the bicarbonate is needed to neutralize gastric acids. We also have goblet cells for mucus secretion, protection of lubrication. The bile juices help with fat digestion, and the digestive enzymes would be entropeptidases, for example. Now this image here shows you the activation of pancreatic zymogens. Basically follows the pattern of all inactive substances that need to be activated in order to do anything. And no details required here, but the hepatic portal system is sort of this supply of blood that is coming from the gastrointestinal tract, has picked up all of these products of digestion, and now we need to run it through the liver, so that the liver, which is a control freak, is getting first dibs on it, and if there's something wrong, it will kick it out. So this here is the hepatic portal vein that drains into more and more bigger lymphatic vessels, and then drains into the venous side of the circulation. For the intestinal phase, we have a few things to consider. So, of course, most of the digestion occurs in the small intestines, makes it a very important site for absorption and digestion. The large intestine only basically concentrates the fecal material. You do have some motility in the large intestine, and that would be mass movements of the bolus of food forward. And then we also have the defecation reflex. I'm sure you've all experienced it, that you have to go to the bathroom, and hopefully you have one nearby. The digestion of and absorption of in the large intestine leads a lot of times to gases. And here they've used the fancy term flatus. Well, it is gastrointestinal gases, and as you know, they can be rather unpleasant most of the time. Diarrhea, if there's any diarrhea that's going on, it can cause dehydration. That's the most dangerous thing, basically, about the diarrhea. Imbalance in electrolytes and then the dehydration. Here's a summary image of the large intestine. You have basically ascending, the transverse, the descending portion of the large intestine, and then you have the sigmoidal colon, and then eventually you're going to have the rectum and the anus region. Same thing, ascending, transverse, descending colon, then sigmoidal colon, and then you have the rectum and anus. Only at the very end you gain some control of the whole process with the external anal sphincter, which is skeletal muscle. Now, the gastrointestinal tract also has other functions. One of them would be here to participate with immune responses. Here you have a lymphatic nodule, and then here is your pathogen, or actually your substance that's causing the problem. Now, if it just involves the longitudinal layer or just the circular layer of the muscle, then you can keep it probably local. The lymphatic nodule is sort of the first place once the process of dissemination or spreading starts of these cancer cells in this case. Then the lymphoid nodule is an important gatekeeper, and that's why people are always being checked about their lymph nodules and lymph nodes. If they are clean, then the chances are much better for survival. Here is an image showing you the very tail end of your gastrointestinal tract, and it will be the rectum and the anus. And so luckily for us at the anus, we have an external anal sphincter, and that's skeletal muscle, and so therefore it is under our control. Can you imagine if it was not? Now, the defecation reflex begins with the stretching or distension of the rectal wall, and then you feel this urge, I gotta go to the bathroom, and luckily you have this external anal sphincter that gives you control over the process. A summary of the immune functions of the gastrointestinal tract. We do have M cells, and they sample the gut contents of the gut. The immune system cells, they will secrete cytokines, and they attract additional immune system cells if necessary, or cytokines that can trigger inflammation and increase the chloride fluid and mucus secretion. So all of that's possible. Another immune function of the GI tract is vomiting. It's a protective reflex that your stomach said the stuff what you just ate is no good and it needs to go, and it's usually right. If you feel the urge to vomit, try not to suppress it, because it is a necessary mechanism to remove stuff from your gastrointestinal tract that shouldn't be there. Now we're left with just a summary. So we talked about function and process of the GI tract, anatomy, the motility, phasic and tonic contractions, and then we talked about secretion and regulation. And here, this is our last slide. The digestion and absorption, the different kinds of enzymes that are involved, like amylase and lipase and all of the other ones. Then we talked about the cephalic phase. It's all in your head. You see the food, you smell the food, you want the food, and you're getting ready, and your salivary glands, they start to secrete this mouth-watering substance because you're anticipating to put some food in your mouth. The gastric phase, that's your stomach, everything around the stomach. It has mucus cells that produce mucus, as you might have guessed. Chief cells, enterochromaffin-like cells, and G cells. We mostly talked about the chief cells, and the mucus kind of cells. In the intestinal phase, we have the brush border enzymes, mass movement, and the defecation reflex at the end. And the immune functions include M cells, and the vomiting is actually considered an immune function. Now, just to point out here some important stuff. The chief cells, they make pepsin or pepsinogen that then gets converted into pepsin with the action of hydrochloric acid. The parietal cells are concerned with the hydrochloric acid production, and so they're the ones that are responsible for the stomach acidity, and also they're responsible for activating the pepsin. So all of these are important functions.